So this is a piece of core that we've collected from South Africa that's approximately 3.2 billion years old. And it consists of many different layers. And the different layers can tell us different things about the environment in which the sample was originally deposited 3.2 billion years ago. To get at those answers, we will take small chips of the rock out of here, we will cut them out, and we will mount them in this epoxy disc. And so you can see many samples here are mounted in this epoxy disc. Once we mount the sample in here, in this epoxy disc, we can put it into the laser ablation system. And once it's in the laser ablation system, we hit it with a high energy laser beam, and it ablates material from the sample, and that ablated material is then transported into the mass spectrometer where it's analyzed for its isotope composition. Once the material is ablated by the laser beam, it travels through tubing to over here to the mass spectrometer. Here, the small particles are introduced into the plasma, which is burning at essentially about 8,000 degrees Celsius. That ionizes and atomizes the particles. Once we have the individual isotopes ionized and atomized in the plasma, they are accelerated through a high vacuum system through this mass spectrometer. The isotopes are accelerated through different lenses and through different series of magnets where the isotopes are separated based on their mass. Once we come down to here, the isotopes are now separated by all their masses, and they're analyzed here in the source housing. Here we collect voltages of ion beams, and from those voltages we can measure the isotope composition of the samples.